Good morning, kids. This is for my algebra class on Tuesday, January 4th. Today, I'm going to be teaching about perpendicular and parallel lines. If you got the email from me over Christmas break about printing out notes, and you printed your notes at home, they look like this. It should start with the words perpendicular and parallel lines. You can go ahead and get that out and write on this as we go. If you did not print this out, it is on Google Classroom, so you can print it out tonight if you want to. As we do examples on the board, you should write those down on a piece of paper, whether you printed this out or not. This printout will have the examples, problems written on it, but not the solutions. So as I solve a problem on the board, you should write it down. But you don't have to write down definitions or anything because these are already printed for you and are posted on Google Classroom. So let's get started. It seems like forever ago that we were graphing lines in algebra. Today we're going to be learning about perpendicular and parallel lines, but also reviewing what we know about the equations of a line. So far, we've learned several different kinds of equations of a line. The three that are going to help us out today are slope-intercept form. That is when an equation starts with y equals. When the equation starts with y equals, and it has something to do with x on the other side, it's in the form y equals mx plus b, and the slope is the number that sits in front of x. We also learned standard form of an equation of a line. That's when an equation is in the form ax plus by equals c. When the equation is in this form, then the slope is not what's sitting in front of x. The slope in standard form is actually negative a over b. So if you need to know the slope of a line that's written in standard form, the slope is negative this number divided by this number. And we will calculate that a little bit later in class. So if you are confused by that, don't worry about it. We're going to come back to it. The final form of a line that we need to know for today is point-slope form. That's when the equation says y minus y1 equals m, x minus x1. So if there are parentheses around the x's with a number outside, and then there are y minus a number on the other side, that is point-slope form. When an equation is in that form, it means that the number in front of the x parentheses is the slope. Again, if you don't remember everything about this form of a line, it's okay, because we're going to see some examples today where we will review exactly what to do with each of these equations. But I wanted to review them real quickly, so when I say slope-intercept form, you'll picture this one. And when I say point-slope form, you'll think of this one. All right, so that was our very quick review on equations of a line. Let's get into what perpendicular and parallel lines are. Perpendicular lines are lines that cross at a 90-degree angle. So everybody in the room, everybody right now, show me with your arms what perpendicular lines look like. That's right. They cross at 90-degree angles. So perpendicular lines look like this. Parallel lines are lines that never intersect. Show me what parallel lines look like with your arms. Good. Parallel lines look like this. They're lines that are both going in the same direction. They will never, ever cross each other because they go on forever and they're always the same distance apart. They might be going straight up and down. They might be going left and right. They might be going diagonally or some other direction. But if two lines are parallel, they will never, ever cross each other. They're always going in the same direction. Some fun facts that we need to learn today. We're going to start with parallel lines. We need to learn two interesting facts about perpendicular and parallel lines today. The first one is this. parallel lines have the same slope. Any set of parallel lines have the same slope. If I give you two lines that look like this, they are parallel, so they have the same slope. If I give you two lines that are going this way, and I tell you, even though those aren't drawn perfectly, I tell you these are a set of parallel lines. That means that this line has the same slope as this line. So no matter which direction your parallel lines are going, if they are parallel, then those lines will have the same slope. Here's an example I have written in your notes for today. Here's an example of equations. Y equals 3x plus 2, and the equation y equals 3x minus 8. These are two different lines. They're two different equations, so they represent two different lines on our coordinate grid. And if I ask you, are these lines parallel? Are they perpendicular? Or are they neither? The first thing you should check to see is, do they have the same slope? Because if they have the same slope, then they are parallel. Both of these lines are written in slope-intercept form. So we look at what's sitting in front of x, and that is the slope. For this line, the slope is 3. For this line, the slope is 3. These two lines have the same slope, so I can say that these two lines are parallel. And if you wanted to graph them, you could. Y equals 3x plus 2. The y-intercept is 2. The slope is 3, which is the fraction 3 over 1. That means I go up 3 and to the right 1. So this is my first line. Y equals 3x minus 8. If I were to graph that, the y-intercept is negative 8. The slope is 3, which is 3 over 1, which means I go up 3 and to the right 1. 1, 2, 3, to the right 1. Draw a line. And even though that's a little bit sloppy, that's a little better. Oh, sloppiness. For my next lesson, I'm going to have to find a ruler to draw lines up here. You can see that the red line and the blue line are parallel to each other. They are going in the same direction, and they will never, ever cross each other. They have the same slope, so they are parallel to each other. If I make the red line a little longer, it would be easier to see. There we go. That's a little easier to see that the red line and the blue line are parallel to each other. So, fact number 1 for today is, if two lines are parallel, it means they have the same slope. What about perpendicular lines? Let me show you some perpendicular lines on this coordinate grid. Here's one line, and here is another line. These two lines are perpendicular. They cross at a 90-degree angle. Do these two lines have the same slope? I don't think so. We learned in class that a horizontal line has a slope of 0. So this blue line has a slope 0. And this red line is a vertical line, so its slope does not exist. So two perpendicular lines do not have the same slope, like parallel lines do. On our handout that you could have printed at home, it says that perpendicular lines have slopes that are opposite reciprocals. Opposite reciprocals. The word opposite means change the sign. If the slope is positive, make it negative. If it's negative, make it positive. And the word reciprocal means flip it over. If you write the slope as a fraction, the reciprocal of that fraction is you flip it upside down. So if you have two perpendicular lines, their slopes will be opposite reciprocals. There is an example in your notes that says y equals 1/2 x plus 5 and y equals negative 2x minus 7. We're going to find out if these two lines are perpendicular. If they are perpendicular, then their slopes will be opposite reciprocals. The slope for this first line is 1/2. M equals 1/2. If these two lines are perpendicular, then the opposite of reciprocal of 1/2 will be the slope of this line, negative 2. Is that true? Is negative 2 the opposite reciprocal of 1/2? Let's find out. Opposite means to change the sign, so I'll need to make the slope negative. And reciprocal means to flip the fraction over. Instead of 1/2, make it 2/1. Is negative 2/1 negative 2? Yes, it is. So the slope of these two lines are opposite reciprocals. That means that these two lines are perpendicular lines. I don't think they're horizontal and vertical. They might look something like this if we graphed them. Perpendicular lines don't have to be straight up and down and left and right. They can be at another angle. So this, if we were to graph these, they would look something like this. We're not going to graph them though because we're running low on time. So let's move on. I think the next thing in our notes are a couple of examples. We have to figure out if these lines are perpendicular, parallel, or neither. And I'm going to take my grid off of my board because I don't think we need it for this. Let's see. Number 1 in my notes has these two lines. Y equals 2/3 x minus 6 and y equals negative 3/2 x minus 14. The question says, are these lines perpendicular, parallel, or neither? So to find that out, we have to look at their slopes. The slope of this line is whatever sits in front of x. It's 2/3. Whenever the equation says y equals, the slope is whatever's in front of x. So slope is 2/3. The slope of this equation over here, since it is in y equals form, slope is whatever sits in front of x, negative 3/2. The slope of this line is negative 3/2. You need to ask yourself, is the slope the same? No, it's not. So these lines are not parallel. Is the slope a negative reciprocal of the first one? Let's see. This first slope is 2/3. The second slope is negative 3/2. They made the slope negative and they flipped it upside down. So that means the two slopes are opposite reciprocals. And I'm going to abbreviate because I'm lazy. They're opposite reciprocals, which means they are perpendicular lines. So we just solved one problem. You do not have to graph these lines. You do not have to do any other calculations. All you have to do is figure out what is the slope. Is the slope the same? No. Is the slope opposite reciprocals? Yes. That means the lines are perpendicular and you're done. You have answered the question. Let's do the next example. We have to figure out if these two lines are perpendicular, parallel, or neither. So y equals negative 3x and y equals 3x plus 8. Let's look at their slopes. Both of these equations are written in y equals form. They're written in slope-intercept form. So the slope will be whatever's sitting in front of x. The slope is negative 3 in this equation. In the second equation, the slope is positive 3. So we need to figure out, is the slope parallel, perpendicular, or neither? Are these two slopes the same? No, they're not. This is negative 3 and that's positive 3. The slopes are not the same, so these lines are not parallel. Is the slope opposite reciprocals of each other? Well, they are opposite, but they're not reciprocals. If these were reciprocals, then negative 3 over 1, when you flip it upside down, it would have to be positive 1/3. So these are not negative reciprocals. They are negative each other, but they're not reciprocals of each other. So I think for this one, the answer is neither. The answer is these lines are not perpendicular and they are not parallel. They are just two other lines. They might cross each other like this if you graph them. So they may cross each other, but they would cross each other in a different way, not at a 90-degree angle. Let's do the next example. Let's see, the next example is y equals 5x minus 9. And y minus 4 equals 5, parentheses, x plus 3. We have to figure out if these two lines are perpendicular, parallel, or neither. So we need to know the slope. This line says y equals. So the slope is whatever sits in front of x. The slope is 5. This equation does not say y equals. It says y minus 4 equals. This one is in the point slope form, not slope intercept form. This is that third form that we reviewed at the very beginning of class, where you have y minus y1 equals mx minus x1. So in this form, the slope is whatever's sitting in front of the parentheses that has the x in it. Here's the parentheses with the x in it. This is the slope. M equals 5. So I figured out the slope. The slope is 5 on the left. The slope is 5 on the right. What kind of lines are these? Parallel. Right. They have the same slope, so they are parallel lines. Let's do the last example. The last example, number 4, has these two equations. Y equals negative 2x minus 4 and 4x plus 2y equals 8. In this equation, it says y equals. When it's in that form, the slope is whatever sits in front of x. Slope is -2. This equation does not say y equals. This equation is in a different form. It's in standard form. Standard form is ax plus by equals c. And at the beginning of today's lesson, I told you when an equation is in standard form, the slope is negative a over b. So let's figure out the slope of this equation in standard form. The slope is negative. Draw a fraction bar. A is whatever sits in front of x. That's a 4. B is whatever sits in front of y. That's a 2. So the slope is -4/2, which is -2. So the slope for the equation on the left is -2. The slope of the equation on the right is -2. The slope is the same. That means that these are parallel lines. Let me go over this last one more time, because in our workbook today you're going to see some examples that are written in standard form. You just need to remember, in standard form, the slope is not what sits in front of x. The slope is negative a over b. That means negative the number in front of x over the number in front of y. So for this example, the slope was negative 4 over 2, which was -2. So you will have 3 types of equations today in your workbook. You will have equations that are written in slope-intercept form, where the slope will be whatever sits in front of x. You will have equations that are written in point-slope form, where the slope is whatever sits in front of the x parentheses. And then you will have equations written in standard form, where the slope is negative the number in front of x over the number in front of y. You calculate the slopes and see, are the slopes the same? Are they opposite reciprocals? Or are they neither? Right now, I would like you to get out your workbooks, and you are going to work on page 159. Page 159, you're going to do numbers 7 through 12. And let me see if there are any on the back that I want you to do. When you finish that, turn to page 161 and try those problems. You might not be able to do all of them, but you should be able to do some of them, numbers 1 through 5. So you are going to start by doing page 159 in your workbooks, numbers 7 through 12. You can then ask the substitute to read the answers to you. The answer key is in a little booklet on the white shelf beside my table in the front of the room. It should be on the bottom shelf of that white shelf, a little blue answer key book. And then, after you all do these and go over the answers, then maybe you could work together with the people around you and try page 161, numbers 1 through 5. If your class behaves, then you will have no homework tonight. And if you are really having a lot of trouble with especially these problems on page 159, you're welcome to email me, and I can maybe send you a video of me going over some of the problems with you. All right, that's it for me for today. Please use the rest of the class time to do the workbook problems. Do these ones by yourself and go over the answers as a class. And then do these ones with the people around you, helping each other if you need help. All right? I will see you in tomorrow's video. Bye-bye.